Hello, I'm Lena Taro. In this video, I'll be showing you how to use NCTM's core math tools to run a simulation. This simulation will help us to answer the question, if 40% of donors have type A blood, what is the probability that it will take at least 4 donors to find one with type A blood? So let's launch the core math tools, and we'll need to run Java to get the core math tools to work. And then when the screen comes up for quick access, I'm going to choose simulation. So in this particular problem, we have a 40% chance of picking someone with type A blood. So I am going to choose rolling a 10-sided die. And let's just step through by clicking start here and see what happens. We can see that this is showing the outcomes for rolling this fair 10-sided die. So I'm going to reset this. I'm going to say that the outcomes 1, 2, 3, or 4 represent a person with type A blood. That would correspond to 40% of the rolls on a fair 10-sided die. So we're going to build a function. Try that again, build a function. And we are going to say that we want to look for A less than 5. That would correspond to rolling a 1 through 4. I'll hit enter. And let's take a look at the outcomes. Let's step through this. So I'm going to be getting a bunch of zeros and ones, it appears. Well, a 1 corresponds to a true statement in Boolean algebra, and a 0 corresponds to a false statement. So was the die less than 5? If the answer is yes, then we'll see a 1 here. If the answer is no, we'll see a 0. So here we didn't have a person with type A blood, but then we did. So it took 2 people to find one with type A blood. Here another 2 people. Then we found one right away, then another 2 people, and so on. So that's what's going on here. But I don't want to have to keep track of this by hand. It'd be nice if the computer could keep track of the zeros and ones for us and keep track of how many times until I saw a 1. So let's see if we can do that. I'm going to reset my simulator here and click on the rule, go to build and select count till C, and I want to count until I see a 1 because 1 stands for the fact that we've found that type A donor. I'm going to click the down arrow here and the down arrow here, and I'm going to run our simulation to see what happens. So we had a roll of 7, 6, 7, 7, 8, and then finally 1 on the die. So we can see we did not have a value that we were looking for. We did not have a type A donor. And then on the 6th roll, we had a type A donor. Let's do this again. Oh, there we found one on the first time. Here it took another 6, and then 2 donors until we saw one with type A, and so on. So I've run my simulation 5 times. Let's run it 95 times. And we'll say conduct. So we have a total of 100 runs of this simulation. Let's take a look at a graph. And let's add the counts to the top of the graph. So we can see that there was 42 times where we saw a type A donor right away, 22 times where it took 2 tries, 12 times where it took 3 times, and so on. So let's go back to our original question. The original question was, if 40% of donors have type A blood, what is the probability it will take at least 4 donors to find one with type A blood? So 4 or more. So let's look at the graph again. 4 or more. So this was 1, 2, 3, 4 or more. It looks like it's 5 plus 7 plus 7. So that's 19. We have 20, 21, 22, 24. So it looks like the probability it will take at least 4 donors is 24 out of 100, or about 24% based on this simulation.